Good, thanks again. I'm Jen Weesey. I will be your moderator for today's webinar. I work with the Grails and Micronaut team here at Object Computing, and we'd like to thank you for joining us today. We are really excited to share this webinar with you, and Sergio, who is joining us live from Spain, will be your presenter. Sergio is a core member of the Grails and Micronaut team here at Object Computing. And in this complimentary webinar, Sergio will explore the multiple testing practices within Micronaut's applications, including API testing, bean replacement, security testing, and more. So by the end of this webinar, you will see just how easy it is to test microservice applications using Micronaut. So with that, Sergio, I'll go ahead and pass it over to you.
Thank you, Jen. Hello, everyone. Let's get started. So welcome to Micronaut testing, or how I like to call it, Micronaut testing tips and tricks. I'm gonna show you how to test common pieces of a Micronaut application and which kind of testing strategies we have been using in some projects. I hope that some of those tricks are helpful to you on your day-to-day basis. So for those of you who are not aware about OCI, so OCI has a long experience in training. So we do software engineering in general. So you can reach to us and we can help you develop an application from scratch. We can help you put someone from our side to work on your team, or just a consultation. We have also a feature that we call support hours, where basically you just hit us an email when you are stuck with a problem, either in Grails, in Micronaut, and we basically help you out. We have in-house the people who maintain both frameworks, Grails and Micronaut, also the Groovy programming language. So chances are that if you are in doubt about how to do something or what's the best practice, those support hours are a great instrument. But one of the things that is close to our DNA is training. We have been doing training for a long time. We do these free webinars every month, more or less. But we do also on-site training. We do also online training as well. And we have some training courses listed in our website. If you go to micronaut.io and you search for the training tab, you will find a link to those. But if you have a particular need, if your company works with Micronaut and AWS and you need a training custom to you, please don't hesitate to contact us, because that's something that we often do, custom training solutions for people. And without those plugs, let me introduce myself. I've been working on the Grails and Micronaut team for the past 3.5 years. I live close to Madrid, in a city called Guadalajara, around 60 kilometers away from Madrid. I write a newsletter called GroovyCalamari.com, which basically is around the Java ecosystem, mostly links about what I am working on or technologies that I am learning. So a lot of Micronaut, Grails, Groovy, Gradle, a lot of Java in general. So if that's your cup of tea, you may be interested. I am Sergio del Amo on Twitter, and my blog is sergiodelamo.es, and I organize a conference called Gritch here in Madrid. And one of the things that I think is quite disrupting about Micronaut is that typically when we talked in the past about testing, we always refer to as this testing pyramid, where in our projects we had a lot of unit tests, and then we had fewer integration tests, and then we had really a couple of really functional tests where we tested the application from the outside. Even those tests were probably the ones that allow us to sleep good at night, because they were really testing the application. Because those tests were so slow to run and so cumbersome to run, we often didn't write them. So in Micronaut, you will see that the application context and an embedded server is so fast to start, and it's so easy to write a test where you will start 3 embedded servers in the same test. that what you will find, or at least that what I have seen in myself and in others, in some big projects that we have been working the past years, that we are more and more writing functional tests, and our pyramid is basically the opposite of where you were used to. So it's basically, we are not constrained by speed, we are not constrained by memory consumption, and I think that leads to better applications in general. Micronaut is a test agnostic framework, same as we are build agnostic framework. You can build your Micronaut applications in both Maven and Gradle. You can test your Micronaut applications with JUnit. You can test it with a Spock. You can test it with Kotlin test or with a spec. There are a couple of options in the Kotlin ecosystem to test. To test with a Spock, which is the de facto standard to test in the Groovy ecosystem. And note that you can test with a Spock both Java applications, Groovy applications, and also you should be able to test also Kotlin applications, but applications written in Java and test it in Spock with Groovy test is quite a common combination. It's, for example, an approach that we have been using in a big client project in the past year and with success. Both the Spock's capabilities and Groovy are especially well suited for testing. So to typically, if you are using Gradle, so these slides are showing Gradle samples, typically you will need to do a couple of things. You will need to add so we are currently using Gradle support for configuring bombs. So you will see that normally you don't specify like a particular version of Spock or a particular version of any of the Micronaut components. And what you do is you reference a bomb file, and those versions are specified there. So this will be your typical configuration. I have here both test annotation processor in Java and also test implementation in Groovy, so that I can define in my test class path both Java beans and Groovy beans. And I have also here the dependency to Micronaut test Spock, which will give me a couple of Spock extensions, which may make your tests much less verbose, let's say. Another change that you probably will need to do is, instead of, you will need to apply the Groovy plugin. Remember, when you apply the Groovy plugin, you apply the Java plugin as well. So you don't need to have like ID Java and ID Groovy. With ID Groovy, that's enough. And with that, you are all set to use to test your applications with Spock. Testing with JUnit is simple as well. When you create a Micronaut application with the MN create app, if you don't specify anything, the defaults by default is to use Gradle as the build system, to use Java as the main class path programming language, and to use JUnit 5 as the default testing framework. So that's what you will get. I have to say JUnit 5 is a big step forward in comparison with JUnit 4. So yeah, it's also a great alternative as well if your team is more comfortable with JUnit and you want to stay there. Yep, plays really well with Micronaut, no problems. Also, if you, for example, decided to create your application with Kotlin and you wrote a MN create app and then you specify the argument lang Kotlin, by default, we will configure for you Kotlin test. And couple of things, you will need to have here KPA test in Micronaut inject Java to have like Kotlin beans in your test class path. And we include a couple of mock dependencies to make your assertions life easier. But we internally like Spock a lot. In fact, Micronaut, the framework itself, and all the Micronaut modules are written in Java and tested with Spock. So yeah, we believe it's a perfect combo. We encourage you to do so as well. You can create a Java application and test it with Spock. That will be as easy as write Micronaut create app, your package, the folder that you wish to create. And you can specify features that will basically modify slightly your build file. So in this case, this will add the necessary Spock dependencies. And also it will generate a file in the root of your project called Micronaut CLI.yaml, which basically specifies the Spock framework as the test framework. When you, based on the configuration that you have in the Micronaut CLI file, when you type mn and you go to the prompt, we have some commands available to you to create common components in a Micronaut application, such as controllers. Here I have an example of creating a controller. If in your Micronaut CLI file you have a Spock, this will generate like a Spock test, right? I personally don't use the Micronaut command line a lot, but it's there. And if you are coming from a Grails background and you love the Grails command line, you probably will like this as well. So check it out. The core of Micronaut is the dependency injection, right? So Micronaut itself, the beauty of Micronaut, in my opinion, is bringing joy again to dependency injection. And it does everything on compile time. So that allows the Micronaut applications to be suitable for scenarios where memory constraints and startup times are really tight, such as serverless. And that's a key scenario. Also, in fast startup time is not useful only in serverless scenarios or when you have containers, but also in testing, right? So you want your test to start embed servers as fast as possible, and that's something that you get with Micronaut, right? So the goals of the inversion of control in Micronaut are use reflection as the latest resort. I believe right now we don't have any reflection at all in the framework. Avoid proxies, optimize startup time, reduce memory footprint, and provide an easier and clear error handling. Typically, you will need to understand or use two classes, the bin context, which is the abstraction that allows for dependency injection of classes, either using @inject or constructor injection. But normally the class that you will interact most is application context. So application context is an extension of the bin context, which adds configuration, environment, runtimes, and typically in your test, you will start the application context with an static method called run, which may take some parameters such as a map of configuration or environments. So application context is one class that needs to be on your tool belt. So when you run and create an application context, by default, we infer if you start the application context on your test class path, we infer the test environment by default. What that it means exactly. So here I have Spock specifications for those of you who are new to Spock. Spock test extends from specifications. You can define them in plain English, and they use a BDD structure. So you basically define these blocks, given a condition, I expect these things to happen, and then you have some cleanup blocks. So here I'm starting an application context. You see application context.run, and I didn't specify an environment, but by default, Micronaut realizes that one of the active environments is test. So whenever you run, when you run the application context in your test class path, the test environment is inferred by default. Here I am doing the same test with JUnit 5. Note I am using here try with resources so that to ensure that the context is closed if anything goes wrong. And yeah, same thing. You see Spock is a bit less verbose because you can access, there are some getters, you can call environment without calling the getter, and you're calling the same thing, etc., etc. There are implicit assertions, so you don't have to specify an assert true. but in general, it's the same thing, right? So it's the same test written in JUnit 5, and this is the same test written in Kotlin test. So again, I am starting an application context, I'm closing it at the end, and I am asserting that this condition evaluates to true. So by default, the environment is test. A Micronaut application can, so typically in a Spock test, unless you want to test, you need to start and stop multiple application contexts in the same test. Your typical structure will be this one, where you basically have an application context annotated with auto cleanup. Auto cleanup is an annotation from Spock, which will ensure that when this thing is finished, it will call the close method. By default, it's the close method, but that's configurable. In our case, that's desirable because we have a close method. And the assert annotation in Spock means that this field will be reused for all the tests that are in your specification. As you see, the test is much cleaner this way. You will have like what you are testing. This is an implicit assertion. So this is the same as in JUnit, you did the assert true here. Micronaut test we will see later in combination with Kotlin plays really nice as well, because you're gonna have like a constructor injection. So here I'm basically injecting the application context, and I can automatically test it here. So yeah, there are some things that in Kotlin they are nice. They are also really succinct, which is something that I like in tests. We discussed that by default you have, we infer the test environment, but you can have multiple environments, and you can have your own environments because maybe you want some beans to be loaded in an environment. So here I am calling the run method, which takes a list. So in Groovy, we can omit the brackets for the list, but this is like passing a list of environments. And you can see that I am verifying that the test environment is still present, and also this new custom environment. So it's possible to run your application context with custom environments, no problem. How do you verify that a bean exists? So one thing that I find particularly useful is understanding when something I don't understand what's going on, is actually checking that the beans that I expect to be in the application context are really there. So if you want to test that this home controller, because you annotated it without controller, is part of the application context, how do you do that? Application context had one really convenient method called contains bean, which allows you to pass a class literal. So in Groovy, what you will write in Java is home controller.class. You don't have to specify the class literal. That's optional in Groovy. So this is doing a assert true context contains bean and the class literal. So really, really nice. You can test that. You can really easy ask the application context whether a bean exists or not. It's also easy to check a property value, right? So when you create an application in Micronaut, by default, we specify like a name based on the input that you passed in the create app command. How do you test which is this property value in your test? So that's easy. You have a get property method where you can pass the key and the class, and this will return an optional. And here I am basically calling get directly in the optional and checking that the thing is what I expect it to be. So really easy to check that the property values are what you want them to be. Same test in JUnit 5. Here I'm using the before all and the after all to basically start the application and close the application context. Same test. And same test as well in Kotlin test. So I am, this is the way to get like the class literal in Kotlin. It's a bit verbose, but yeah, as you see, it's no different than the other scenarios. How do I verify that a bean doesn't exist, right? So imagine you forgot to add the add controller annotation. You could use the contains bean, right? but you could use also what happens when you call get bean and you try to get a bean and the bean doesn't exist. An exception is thrown, and that exception is no such bean exception. So whenever you call a get bean and you try to get a bean, but the bean doesn't exist, you will get this exception. Spock has a really nice and powerful capabilities for dealing with exceptions. And that's important, especially in, when using the Micronaut HTTP client, because Micronaut HTTP, I will go into that later, but yeah. If you have to decide which testing framework you want to use for your Micronaut applications, exception handling, nice exception handling should be in the top of your list. JUnit 5 has these assert throws, which will basically give you the same thing. So yeah, as I said, JUnit 5 has really nice improvements in terms of exception handling in comparison with JUnit 4. So one thing, if you inspect the Micronaut core code or other modules code, you will see one pattern that we have been using. And we have been using to avoid bean pollution. So when you have like a test, you have a lot of tests, and for some tests, you need just to create one particular bean. It's really important to basically constrain that bean is only in the application context that is started in that single test. So you don't want that bean to pollute your application context for other tests, because that may be problematic to debug, right? Because something may be happening that you are not expecting and you are not understanding, and what is happening is that a bean that was created in another test is actually the one that is being used, right? Or the one that is modifying your expected behavior. So how do you create beans in test class path? So if you want to have Groovy beans, you will need to have, so this will be test implementation in the newest version of Gradle, but you will basically need to have the Micronaut inject Groovy dependency, and in Java you will need, if you can have Java beans in an Spock test, no problem. You can have like source test Groovy and source test Java. But if you are using like JUnit 5, for example, and you want to have like Java beans in your test class path, you will need to have as a test annotation processor the Micronaut inject Java dependency. And for calling, you will need the dependency to be in KPT test. So one thing that we are leveraging and using a lot is the add requires annotation, which basically allows you to have, you can have multiple add requires annotations, and basically are conditions that need to be evaluated to true in order for a bean to be loaded into the application context. So what you will see is we are using this spec.name property and a value. So here I have an extra bean, which is annotated with a singleton. So this bean, when registering the application context, will be a singleton. But it will be registered in the application context only if the property spec.name is found and has the value extra. So what do I mean? So if I start my application context with, you see here I am supplying a map, a Groovy map. So I have here a spec name, the property name, and the value, right? If I call get bean, I don't get any exception, right? So that means that this bean has been loaded in the application context. However, if I run the application context without supplying any map or any configuration map, I get the no such bean exception. So we are using this a lot through the framework, and I encourage you to use it because it's really useful to keep bean pollution to a minimum. You will see a lot of tests where we have like a static class and a new bean here created with, annotated with add requires, and here this bean to be start the application context with a particular spec.name value. I will show you the structure that we have been using in a big project. Maybe that's an inspiration for you to use. The thing that is probably the coolest thing is how easy it is to start an embedded server inside a test, right? So to start an embedded server, that's as easy as pass the run method in the application context has. You can supply embedded server.class, and that will basically start the embedded server. By default, it will start it at a random port in the test class path. The embedded server has a get application context, so you can get the application context from there if you need it. And we will see how easy it is to point an HTTP client to that embedded server. So really easy to test your controllers. Again, starting a server in a test is really, really fast. So that's something not to overlook. How do you test your endpoints in Micronaut with the Micronaut HTTP client? Really easy. Imagine you have this controller, which is listening in the root of your application. And we have this annotation called @status, which basically means even if my method doesn't return anything, this controller will return automatically 200 OK, right? And this is expecting a get. And I don't have any qualifier here, and this is the default qualifier. So basically, this is the root of my app, right? So localhost 8080, and this will return 200. So I can start my embedded server, application.run embedded server. It's annotated with auto cleanup to close when it's done. And then I can call HTTP client, create, and here I can pass the embedded server URL. This is not creating a bin, and this has some drawbacks. I'm showing it here because I want to show you both. So this is a way of creating an HTTP client in a test. This is not the desired way, but it will basically give you an HTTP client which points. We have a fluid builder in HTTP request class, which allows you to compose requests. You can specify the HTTP verb. You can specify some headers, etc. So really, really easy to create requests. Here I am calling client to blocking exchange. So typically you will engage with two methods in a test, either with exchange when you care about the HTTP response envelope, when you want, for example, to check the whether the HTTP status was 404 or 403 or whatever. And when you care only about the body of the response, you will use the method retrieve instead. So let me go to next slides. HTTP client response exception. This is really important in test. Basically, the Micronaut HTTP client, when you don't receive an HTTP status code of in the 200 range or 300 range. So when you get anything from 400 or 500 or 404, all those HTTP status codes will be wrapped in an HTTP client response exception. So for example, if your app is not on auth, if you are trying to hit an endpoint that is secured, you will get a 401. That will be an HTTP client response exception. So if I try to, for example, hit a post request against my endpoint, which was only I was accepting a get request, that will get basically a method not allowed exception, right? So which is a 405, I believe. So really important to capture exceptions. This is another way that before I show you thrown with the class between the parentheses, I like this way better when I need to introspect the exception, which is you define the type here and you call equals thrown, and you have the exception here, and you can call the status code. You can also call response.body, and that will give you the body of the request. You can use declarative HTTP client as well in the test class path. So I could have, you see here, I have this class under source test Groovy. I have this pointing to the root of my app. I call this method index. I could call it any name. And this is a get request against the default, which will be the root path. And I can basically get this bin referenced, which will be automatically picked by the application context. And I can basically call the method index and get the status code. So if you want to use declarative HTTP clients in your test, that's absolutely possible and sometimes a cleaner approach. Validation. So Micronaut has some powerful validation. So to use the Micronaut validation capabilities, you will need to have these two dependencies on your application, both in annotation processor and implementation. here I have, for example, a pollo. You will have to annotate your class with at introspected, which will have, so basically my rule of thumb is all the pollos in your applications should be annotated with at introspected, and any pollos that are used, especially pollos that are used as controller parameters or controller response types. But in general, what we have done, and I believe that's a good call, is we have kept our pollos really simple. So basically, yeah, fields and getters and setters and an empty constructor. All those classes are annotated with at introspected, and they are annotated also with the JavaX constraint classes. So here I have, for example, maybe for a registration form, where I have a username and the password needs to be 8 characters at least, right? So you can basically get the validator. That's java.x validation validator. That will be basically set up by Micronaut for you. You can get the validator bin, and I can call .validate in a pollo. And you see here I have one pollo with elementary as a password, which has more than 8 characters. And then I have 12, which has only 2 characters. So this method returns the list of constraint violations, I believe. And you see the first one is valid. It doesn't have any violations. And the other one is not empty, that it has violations. So this is a really nice unit test for basically checking that you have properly remembered to add the constraints to your pollos. You can also test this in a service, right? So what we have been using is in a service method or in a class, you can have like, you typically will add the not null annotation because you don't want this parameter to be null, but you also want this parameter to be valid. So you want those constraints that are defined inside this pollo to be valid, right? So in order to do that, yeah, you will basically pass a registration command, and if the validation fails, you see secret has less than 8 characters as well, this will throw a constraint violation exception. So what we have been doing is we are always like creating interfaces for defining contracts, and we have like a lot of constraint tests. So we are confident that the data that is going through the system is valid. And that's, I think, a really way of coding defensively, and I think it makes for more robust applications. So another thing that you can do in Micronaut applications is to serve static resources. So that's really easy to turn on. Here I am turning, I will place my static resources under source main resources static. And they can be referenced from the root of my application, etc. So what I want to do, I want to serve a logo, and then I place my logo under source main resources static images logo. And the test will be as easy, as basically I'm starting the server and I'm doing an HTTP request / images logo, and you see my serving static resources is working properly in my Micronaut application. So if you are serving static resources, remember to add this test because sometimes we never test this kind of logic, and anyone changing the configuration may break those. That, and if you don't have a test, you basically are blind to that. How to test the UI with JEP? So in Micronaut, typically you will build applications. So Micronaut by default responds JSON and expect JSON, but you can build applications with generate HTML on the server side. So we have support for many views technology. For those old enough, you may remember Velocity. From when we were building stats applications. So we support Velocity and many others. To use Velocity, you will add something like this, where you will have the Micronaut use Velocity dependency and the Velocity dependency itself. In your controller, you will specify the view that you want to be rendered. And typically here, you will return the model that the view will use to get populated. Here, my view is a plain HTML website, which you see I am placing under source, main resources views, and home. It's not a coincidence that home matches my home, my view annotation value. So how do I test that when I go to the root of my application, an HTML page is rendered where the title of the HTML page is Micronaut? JEP comes to the rescue. So JEP is an abstraction on top of Selenium, which makes it brings back the joy of doing UI tests without the pains of Selenium. So that's JEP is a completely different topic, but what I just want to transmit in this webinar is that we play well with JEP. So I am here adding the latest JEP dependency, and I am HTML unit drivers. JEP has support for using Firefox, Chrome, Firefox headless, Chrome headless. So HTML unit probably is like your first line of defense. But if you have like a lot of UI, you probably want to explore other drivers. You have typically a JEP config file where you can have multiple environments. So you can test like your app with multiple browsers. Here I'm testing just with HTML unit, and I am also setting the default as HTML unit. Typically JEP uses a page model. It's not required, but it's like the best practice and my personal recommendation to use pages a lot. So here I have a page where JEP has a DSL where I say this page is for the root URL, and this is a condition that this page is evaluated to, and I say that the title that you saw defined in the HTML head is Micronaut. And this is a JEP test. Typically JEP, if you are using Spock, they will extend from JEP spec. Here I am starting my embedded server, and here is the key. Basically, I'm telling that my browser that the base URL is the URL where my server started, and from then on, you will test JEP as usual. So this is evaluating the add condition. JEP has a lot of it leverages a lot of the Groovy capabilities. So if you are not familiar with Groovy, this may seem like magic, but this is usually like optional parentheses, method delegation, etc., etc. So how do I override configuration for tests? So if you have in source main resources application.yaml this configuration, I have company address Luis. You can create a file under source test resources application/test when you can override that value in your test. And here I have a test that basically shows that, right? If you write this test, you will see that the application dash test.yaml that you have under source test resources takes precedence to the other one. We have a micro testing framework, which basically is not a mock. It's starting the same embedded servers and application context that I have been showing you. It's really useful. It has a couple of nice features that we use in projects, especially the mock bin, which I will show you now. And sometimes can make tests less verbose. So check it out. You go to micronaut.io, you go to the docs. We have a link to the micro testing framework. We have support for both JUnit, Spock, and I believe we added Kotlin support as well lately, but not 100% sure about that. This is how it will look like. You add a micro test annotation to the class, and you don't need to start the server. This starts the server for you, and you can automatically use the @inject annotation to inject your bin, and you can call the bin directly. So this takes care of starting the server for you. And yeah, just to make clear, this is the real app. So this is not like a mock or anything like that. The Micronaut test is starting the embedded server, so it's starting the real deal. Yeah, you can inject application context as well. So you are not limited to inject in a particular bin. You can inject the application context. You can inject the embedded server if you want to create you want to call like a embedded server application context create bin. So many possibilities. This is something that I wanted to show you. This is an important thing is, imagine you are building this application, the Micronaut application that is consuming another REST service. So we have this URL, startgrace.org.version, which returns a list of strings, and some of strings contain a build snapshots. And this basically is a GET request against this URL. So this start.grace.versions, and this returns this list of strings. And I want to have an endpoint in my Micronaut application with this /grace version, which returns this list of strings. So how does this work? So this is the cool output of the thing that I was describing, right? So this is what I like to do. I create an interface called Grace Client, which basically defines, when I call the method versions, it returns a list of strings. Then I have a class, another interface annotated with @client. This is my @client identifier, which is Grace App Forge. This is the name you pick. And this extends from Grace Client. So I am overriding the method and I am adding the get. I am telling that this is a get method against the versions endpoint, right? How do you tell Micronaut where is the URL for that particular HTTP client to that particular declarative client identifier? The easiest way to do that probably is to, in configuration, have Micronaut HTTP service. This is my @client identifier. And here I can supply a URL, or we support even the plural URLs. And you can have like a list of URLs and we will load balance between those. So I am telling that basically by default, this is the one. And this is my controller. I am using here constructor injection. So I am injecting the Grace client bin. This controller is /grace/version. This is producing, it's not JSON, it's just a list of strings. And here I am calling the client, which for me, this is transparent. I don't know if actually this is an HTTP client or what it is. Basically, I'm using Java Streams API to remove the entries which ends in build snapshots. I only want to expose here my stable versions, for example. So how do I test this thing? I can test these things with basically a request. I can use argument list of to get a list to basically bind the body to a particular type. And this is important. So this in other implementations is really cumbersome, and with Micronaut it's really easy to bind a body of a response to a list of a particular class. In this case, it's a list of string, but this could be a list of Pollo. So remember argument list of, and that's a really useful thing to have under your toolbelt. So instead of using Grace Application Forge in our test, we want to basically mock that, right? So I'm gonna show you different ways to test this thing. First one is using a Micronaut test framework and the mock bin. So how does this work? You basically, I have the class annotated with Micronaut test. And here I have a method which returns a Grace client, and it tells mock Grace client, which is the interface that I created. And I'm telling which bin I am mocking. I am mocking actually the @client bin, right? The Grace Application Forge. And here, this is Spock. So this is, I am telling, this is the way that the Spock defines interactions. So this test needs that this method is called at least once. Actually, it's called one time. And the time that is called is going to return this list. So basically what I am saying is that when we try to call the method versions in the Grace client, is returning this thing, and we are testing that we are calling it once. And this is one way, really nice way, where Micronaut test and mock bin is a really nice option. Another way, this works as well with HTML Unit 5, with JUnit 5, sorry. So yeah. Nothing special here. Second option is to use @replaces. So in my test class path, I could replace the bin. So I could replace the Grace Application Forge, and I could say that instead of that bin, I want to use this Grace client replacement. And basically in my test, this class will be used in this. This is the class that will be the bin of type Grace client instead of the other one. So @replaces, and here you tell the class that you want to replace. And the replacement needs to be of the same type. You need to implement the same contract. Yeah, the test will pass. Actually, you don't need to, it's the same test that I originally showed you. So completely transparent from the test. Another option is, instead of replacing, you can annotate with @primary. So when you call getBin, if there are several bins of the same type, if one of them is annotated with @primary, that one will take precedence and that will be the one returned to you. So in the controller, the bean of type Grace client annotated with that primary will be the one used. Another one is to use the fallback. So we were using an HTTP client, right? So if the HTTP client is not responding because the star.grace.org is down, the fallback is used, right? So first, Micronaut will try to use the Grace application forge bean. And if that bean, because it's an HTTP client, is failing, it will use the fallback instead. So you can have this fallback in the test. And what you could do is here, I am in my test, I am pointing the URL to a bogus URL, to a URL that I know that is going to fail. And you will see that the fallback is used instead. So another option. Typically, fallbacks more than for test, I will use it in the real apps. But it's another option as well. Another option is to use ersatz. Ersatz is a mock HTTP server for testing client code. I'm a bit short on time, so I'm gonna skip through this because my recommendation is to use actually to mock another HTTP server with Micronaut. So you can start 2 applications in the same test. So what I'm gonna do is I'm gonna create another controller called mock versions controller. So this is like the controller that is like for the second app. And I am constraining to the spec name mock HTTP server, right? And here what I am doing is in my test, I'm calling socket utils. This is a Micronaut class, which will give you an available TCP port. Basically, I'm telling Micronaut to start this app in this particular port. And I am telling this app that for this app, spec name is this value. I am verifying here just to show you that in this embedded server that I just created in this test, this bean is present, this mock versions controller bean. And here, when I start my principal application, what I tell is that the Grace application forge URL, I tell it to use the other one. And I know that the other one is basically localhost and the port that was available and the one that I used to start the app. So basically I'm starting 2 apps and I am pointing the first app to my second app. And then I can use it as transparently. So this will do an HTTP request. So this is like the closest thing to reality. Instead of depending of third-party service to be up or to record traffic, what you do is you basically create a second Micronaut applications with the endpoints that you need for the test. And you verify that actually your HTTP client is working and you can try logic like retries, etc. So this is a really nice and powerful way. So one thing that you can do is also have beans that you don't load in the test environment. So maybe you could annotate the Grace application forge to not be loaded in the test environment. So that's another option. How to test a specific configuration. So we have a really nice support to load configuration via configuration properties. So one thing that you can do is the Micronaut test you can combine it with add property. So you can say for this particular test, I want these properties to be these values, right? So this is another way where Micronaut test is really, really succinct and nice to read. This is the same thing, but manually starting the embedded server where you supply the configuration in a map, right? Exactly the same thing. You can also specify additional property sources. So you can have like under source test property, I can have here contact properties where I have like a properties file. And I can in Micronaut test, we support like to pass like I can say load these property sources, and this will be a successful test as well. I have not used this a lot, but this is another option for you. How to test security. So typically this will be your setup for security. You will have to turn it on and you will have to need these 2 dependencies. You will have to annotate your controller. So this controller is secured. You will need to have to pass a token, basic auth, whatever the security you are using. But basically, this controller, if the security challenge fails, it will return a 401. So one way to test this thing is to disable security and test the controller as you will normally do. to disable security, you basically, you pass Micronaut security enable false when you create the server, and security is basically disabled, and you can do a get request, and yeah, no problem. If you do that, then create an additional test where you test that the controller is secure. So this will force you to have like two tests, one test where you are testing security, and in the rest of the test, you are not testing security. How many times do you need to test security? Once, right? So you need to have one test that ensures that that controller endpoint is secured, but you don't need to test security multiple times. So that's one way to do it, and it will have some side benefits because, yeah, your test suite will be faster because you will not engage the security filter for every test when not necessary. This one option is to basically get fancy and create an authentication provider in the test class path, which basically, if you supply user and password, automatically authenticates you and create an HTTP client filter, which basically decorates your request with that basic auth challenge, and that will basically be picked automatically for you. That works, and I have used it in some project, but it seems like too clever. So my recommendation is disable in the test and then have a test that actually verifies the security. If you need some logic in your application where you need basically your application will behave differently depending on the role of the person, then you will need to like generate the bearer token or act accordingly. But if your test, if the controller behavior doesn't depend on the currently authenticating user, then you don't need to do that. This is important. I always mentioned it before. So when you create an HTTP client using the HTTP client create a static method, this will not put this HTTP client in the application context. This will put the HTTP client in the application context. So this is the desired behavior if you want your HTTP client to be in the application context. You use application context create bin, not to call the HTTP client.create method. If you are, I am running low, but yeah, I'm gonna wrap a couple of things and we can leave some time for questions. So one thing that I want to just go fast is if you are using JPA, for example, and so Micronaut doesn't need class path scanning, but JPA does need class path scanning. So if I have this class annotated with identity, in my test, so give me 1 second. My configuration probably is JPA default package to scan, and I have the package where those entities are. If I have like an class where I am basically using to persist that entity, in order, and I have a test for this particular class, I will need to test, Micronaut test has the packages attribute that I can tell which packages for JPA to scan. So if you are trying to, if you are writing a test against your JPA classes and it's not working, chances are you are not telling which package to scan. So yeah, that's something to bear in mind. Test container. We were using test container in our application. So instead of using H2, we're using MySQL in production. And all of our tests were using MySQL as well. And we're using MySQL to test containers. What you will need, we were having these two dependencies, the test container Spock dependencies and the MySQL dependencies. We have one class where we were creating the MySQL container, and we had a couple of static methods to init the MySQL container and destroy it. We had a fixture. I will go into this now. But basically this will retrieve some MySQL configuration. And if the MySQL container was not yet started, it will start before returning the configuration. And we had one Spock abstract global extension, which was ensuring that the MySQL container was destroyed. We have been working a big project in the past year with many microservices written in Micronaut, and we were using this structure to test it. We had several abstract parent classes. If we needed to test where we needed the application context static, we were extending from application context specification. Application context specification was implementing a couple of Groovy traits. For those who are not familiar with Groovy traits, they are similar to Java default methods in interfaces. So, and they can extend one, they can implement other traits. So before I show you the MySQL container fixture, so basically we had in every project, we have a configuration fixture, which was returning a configuration map. And this, if the test override the get spec name method, it was basically putting in the configuration, the .spec name convention, and we were also putting the MySQL configuration by default. Application context with an abstract class, which extends from a Spock specification and was implementing configuration fixture and leakage detector. I will go into leakage detector now. It was starting the application context, and in the cleanup method, it was ensuring that no leakage. So we didn't want to have pollution in our database. So the leakage detector was another trait which extended from repositories fixture. And basically was using in this example, I only have one repository, but typically we'll have like 10 repositories here for the entities in our applications. And we were ensuring that when the test finished, the database was empty basically. So if the database was that empty, that means that the programmer forgot to clean up the database correctly in the test. And this is our repository fixture basically. It's another trait which basically returns the user repository. So with this structure, which makes it complex, it's actually really nice to test. You extend from application context specification, and basically you have all the repositories available to you to use. So they are beans that are exposed in Groovy. When you have like get user repository method, you can call user repository. So it's transparent to you. So this is the reason why this method was called get user repository, so that I could call it here like it was a field in my class. I could call here a user. I could do a test that my database count increments. If I forgot to add this cleanup, the leakage detector will fail here. Will fail here in this cleanup. So if I forgot that, this test will fail. And we had the same concept for an embedded server. We had in the embedded server, we were extending from a specification as well and from configuration fixture and leakage detector. So if you actually needed to test your controllers and you need the whole server to be started, instead of extending from application context, you will extend from embedded server. And when we, in the abstract class, we were starting the server, you see we were supplying this is the get configuration that is in the configuration fixture. So this is basically using all the configuration that I can overwrite in my particular test. You see that I am also exposing application context retrieved from the embedded server. I am creating an HTTP client pointing to the server. And we are actually, since normally in your test, you want to be blocking, we have a get client method, which was returning the HTTP client to blocking. And we were also calling in the cleanup. So what does it mean in a real scenario? So in every application, we were always enabling the act-to-actor endpoints, health and info. So this is a test that when I hit a get request to health and to info, in health, we are getting like a status up, and this is a JSON structure where there is like a JSON key called status. And we basically modify our info endpoint to return the version of the application always. So yeah, really easy to test. You have the client here available for you. This is the client defined embedded server specification. It's already blocking, so you can call exchange directly. No need to call to blocking here. And yeah, we have been using this structure for a long time and with quite success. I ran out of time. I had some slides about testing function, but not important. I prefer to have some time for Q&A. So thanks, everyone.
We have 2 questions that had come in that we can go ahead and answer live. So Sergio, one of the folks wondered, what if you try to use @primary annotation on multiple beans?
If you have 2 beans of the same type with a primary and you call get bean, you will get an exception, I believe, because the framework will not be able to tell you which bean to use. But you can have multiple beans of the same type. So sometimes that's desirable. You can have like application context gets beans of type. So you can have multiple beans in an application context of a particular type. That's something expected. But if you need the framework to basically, if the framework needs to decide which bean to use, it has to be clear to the framework.
All right. So that looks like it's about it. And we're going to go ahead and wrap it up for today. Thank you all again so much for joining us. And we hope to see you on our next webinar. Thank you.
Thank you, everyone.